Good evening. I'm Hope Preston, and this is our monthly speakers series for the Washington County Master Gardeners Association. And doesn't tonight make you glad that we have Zoom? I am very happy tonight to introduce Jake Barker and Sarah Lowe, who are going to be presenting about forests in flux, which is a very timely topic. Jake is originally from Colorado. He went to college in Vermont and got his master's in forestry at Yale and has worked in various places, but has ended up out here working he is the Oregon State Extension Forester for Washington, Yamhill, and one other, Washington, Yamhill, and, or Columbia, Washington, and Yamhill counties. I got that figured out. So Jake, welcome. We're delighted to have you. And Sarah Lowe, his co-presenter, is she's an associate professor of practice at the Department of Forestry at OSU. She got her master's at the University of Massachusetts and has been working with trees in various capacities for 20 years, mainly in Tacoma and Philadelphia, and now here in Oregon. So I will turn it over to you just as soon as I say that if you have questions, please put them in the Q&A and we'll address them at the end. So Jake and Sarah, I turn it over to you.
Sounds good. Thank you, Hope, for the friendly and great introduction. And hello, everybody who has joined. I'm seeing a large list of folks, so that's very exciting. Thank you all for being here. And it's not sure where you're tuning in from to where you're turning in to from, but it's raining where I am. And after today's talk, I think you'll be even more grateful for the rain than you maybe already are. And I also want to say thank you again to Sarah. I was in discussion to join for tonight almost a year ago, I think, and Sarah has recently joined our team, and I'm really excited for her to join tonight and to provide more of an urban context as well. So, without further ado, I'm going to hop into this. And first off, just a schedule of what we're hoping to cover today. We don't have a whole lot of time, and some of these topics are rather enormous. So we're going to do our best to zip through these and leave plenty of time for questions at the end. So we're going to start with some big picture climate and forests. We'll move into tree declines and some novel threats. We'll talk briefly about resilience. And then Sarah's going to talk about tree health in urban and suburban landscapes. And then we'll talk about diagnosing tree health before moving into questions. This is a photo from an OSU extension or an OSU College of Forestry research forest out in Washington County near Hag Lake, the Matson Forest. It's a beautiful fall weather out there right now. But first, I wanted to introduce some new folks who have joined the team at Oregon State University's Forestry and Natural Resources Extension. So one of them is Sarah Lowe here, but then she also has joined with a new urban forestry specialist, Jennifer Killian, as well. We also have a new Christmas tree specialist, Priya Rajarapu, and also John Riggins is our new forest health extension specialist. So it's super exciting to have these folks on board. They are joining the team. The urban forestry specialists are new positions, but Priya and John are taking over the mantle from some longtime forest experts who are still in the community, but have moved on towards retirement. So welcome to the new folks. All right, so some big picture stuff around climate and forests is that across Oregon, temperatures are getting warmer. Oregon's annual average temperature increased by 2.2 degrees Fahrenheit per century since 1895. Now, this chart here shows maximum temperature recorded since 1895, with a trend line in blue showing that change over time. And similar to maximum temperatures, the minimum temperatures are also increasing. And these changes in extremes have led to many updates and changes, including the update of the National Plant Hardiness Zone. So this is super significant. Precipitation is projected to increase during the winter and decrease during the summer, and the intensity of heavy winter precipitation events is projected to increase. Without considerable reductions in greenhouse gas emissions, annual temperature in Oregon is projected to increase by at least 5 degrees Fahrenheit by 2074 and 7.6 degrees Fahrenheit by 2100, and with the greatest seasonal increases coming in the summertime. The chart here shows observed in the bars at the beginning in blue and red, and then projected changes in Oregon's average annual temperature relative to the 1950 to 2014 baseline. And then the projections to the right, which are shown in orange, are under three different emission scenarios, ranging from the low pathway to the medium pathway to the high pathway. Um, so essentially, the solid lines that you're seeing here are mean values of simulations that were run by climate models. So this just gives you a sense of what that annual mean temperature might look like under a variety of different emission scenarios. In a similar chart, this is showing the observed bars of precipitation on the left and moving into projected changes. And this is for Oregon's annual precipitation relative to that 1950 to 2014 baseline. So here what we're seeing too is that increase of average precipitation. The average, the bars have been smoothed out for legibility, but showing that there's likely going to be an increase of precipitation coming in more severe circumstances, usually during the winter. Another great resource that I have looked at frequently and is great to keep an eye on is Oregon's Drought Monitor. So this reports bi-monthly on drought conditions across the state and provides details about temperatures, precipitation, and other growing conditions. So here is just a snapshot of the report from this past year. And so it starts in January with a small bit of drought in the northeast corner. Moving into April, we've had some rain, so there wasn't any drought condition. Moving into July and October with more drought. That's just 2025. If you look down the lower section here, we've got um, we've got drought across the years, and you'll see that the biggest peak there is in that 2021, 2022 range, which many of you might remember of the heat dome. I personally wasn't here for that, but it continues to have ramifications in my work almost every day. That we had that really crazy high temperature summer heat dome, and that amplified existing drought conditions across most of the state. So while we do, there is variability within this, it continues to be a persistent problem and has significant impacts on our plant communities. One thing that I like to point out is that drought monitor is helpful, but it can also be a little confusing. So, for instance, this is what I've been calling dry January from 2025, where the map from the report shows that we're not really in a whole lot of drought besides in the northeast corner. But if you look at what the percent of average precipitation was across the state, it was extremely low. Um, so these are the same maps from January 21st, 2025, but precipitation was below average statewide. And in Western Oregon specifically, precipitation was 2 to 8 inches below average. This also leads to indicators showing that soil moisture was decreased across a lot of the state, especially in Western Oregon as well. So with these changing precipitation patterns and higher temperatures, we are also seeing changes to water table dynamics. This is especially important for our tree species that have grown in certain hydrologic conditions and have grown used to them. So one I often see is Western red cedar that's growing alongside streams or in draws, especially seasonal streams. Because Western red cedar doesn't have a deep tap root, they're not as capable of tapping into that lower water table. Um, so when we have this changing condition where with warm temperatures, with persistent drought year to year, and that water table lowers, the plants that have grown in a condition where water was available, they're no longer able to adapt to that changing condition. This is a really helpful diagram that I've found to describe what it might look like, that we've got these changes in precipitation. We're not getting as much water flow coming down from higher elevations into lower elevations. And even with higher intensity water events and precipitation events, it's shown that it's not enough to actually recharge these ongoing persistent drought conditions. Increasing temperatures and hot and dry conditions in the summer is also driving up average vapor pressure deficits, or what we call VPD. VPD is a measure of the difference of the amount of moisture in the area and the amount of moisture that air could hold. Sorry, the amount of moisture in the air and the amount of moisture that the air could hold. So it's that difference in what the pressure could be. Here it's shown in kilopascals, which is just a measure of that pressure. And this has a very significant impact on the ability for plants to grow. When VPD is low, plants can keep their stomata open and they can continue to transpire. I often think of tropical rainforests and high humidity, or being inside of a greenhouse where it's warm and really humid. In those conditions, the VPD is very low, so plants can continue to keep their processes rolling. When the VPD is high, evapotranspiration is higher, so more water is pulled out of the plant. Think, think desert conditions. In these conditions, the stomata close, CO2 uptake is reduced, more nutrients are pulled from the roots, and the plant experiences more stress. What's really cool about VPD is that it can be measured on the ground using ground measurement techniques, but it can also be measured using remote sensing. So this is a really excellent resource that I highly recommend checking out called the Climate Toolbox. And you can select your specific location, but you can also look at vapor pressure deficits and those changes over time and then projected changes all based on remote sensing. We don't really have time to get into like how that works, but there's a lot of really great resources online to learn more about how companies and organizations and agencies are using satellites to look at vegetation conditions on the ground year to year. So because I'm in the forestry department and we talk a lot about forest trees, I thought it was important to mention a recent study that I think is super significant in this regard as well, looking at VPD impacts on growth rates. So this is a recent study by OSU researchers published in 2024 in Forest Ecology and Management that looks at the impacts of summer VPD on growth rates in 50-year-old Douglas fir stands at the H.J. Andrews Experimental Forest. In this study, they investigated how inter and intra-annual rainfall and VPD correlated to the radial growth of trees, as well as the carbon isotope signature, which is a complicated thing, but is a proxy for water stress. And they were looking at the late wood development within a growing year for this 50-year-old stands, in these 50-year-old stands of Douglas fir. So there are four charts shown here, and it's kind of a lot of information, so I'm going to try to distill it relatively quickly. In the upper charts, we're looking at the relationship between soil moisture deficit and, on the left, we're looking at the charts that compare the relationship between soil moisture deficit and changing VPD. So that's the left charts. The right charts are looking at soil moisture deficit and changing rainfall. So we don't need to think too much about the numbers. It's mostly just looking at predicted changes. But what you can see here is that in the rainfall side, the predicted changes are staying relatively close to that normal amount. So the changes aren't as significant when rainfall changes. Looking at VPD, though, there is a more significant impact on that on the soil moisture deficit. As that increases, the VPD also is changing. So essentially, this is a really complicated study, and I was not involved, so it's a little bit over my head actually. But the big picture is that VPD influenced both radial growth and that carbon isotope signature, so that proxy for water stress. And it was actually more than rainfall in this study. So it's complicated because sometimes microsites and water availability within microsites influence late wood production in Douglas fir, but their conclusion is that increases in VPD, which are projected to occur in the next 10, 20, 50 years, that especially during the summer, those conditions are likely to reduce late wood growth and increase water stress in Douglas fir across the Pacific Northwest. So this is huge because this has significant implications for forestry. So it's reduced productivity, trees aren't growing as quickly. And the big thing too is that one of our main approaches for dealing with increasing temperatures, but also drought, is to take thinning approaches in our forest stand to reduce competition, especially root to root competition in the soil. But if our main driver of that change of growth is not soil moisture, but it's actually VPD, so that pressure deficit that's going on in the atmosphere, then maybe thinning isn't the best approach. So this is really significant, and it's emerging research around the factors that are influencing tree growth. And it has implications for Douglas fir, but it also has implications for all other trees across the landscape, whether you're in the forested context, in the urban context, or in the peri-urban context. So if you want to learn more about this topic, there's a bunch of research going on around this. Two resources that I will point out here is sort of an ongoing series that OSU Extension is working on that are looking at forests in a changing climate. But we have two of these publications out so far, and we're currently working on the next sort of iterations, or not iterations, but chapters. But this can be very helpful to think more broadly about how forest managers are thinking about climate change and influencing and how that is influencing their management approach. So one thing that I do like to include in talks around tree and forest health is to just quickly distinguish between tree health and forest health. To some people, this might already be obvious, but I think it is helpful to just remind ourselves what we're talking about. So a sick and dying tree does not necessarily represent a health problem for an entire forest. So how do we talk, or how do we define a healthy tree? Arborists are often talking about achieving a balance for each tree, of having a friable soil, a proper balance of nutrients, sufficient quantity of nutrients, enough root and crown space, and ample water, optimum temperature and light, pure air, and freedom from pests and diseases. So that's a pretty long list, right? For every tree, they're hoping to achieve that balance. Now, in a forest context, we often start considering forest health by looking at individual trees, right? We're seeing symptoms of decline or death, and we go in and figure out what's going on here. But our approaches in a forest context are going to be less tree specific than how an arborist might treat an unhealthy tree in a city or near a home. Tailored care of individual trees is often very expensive, and it's not typically feasible at the forest scale. Forest health is based on a myriad of factors, such as the forest's age, the structure, composition, function, vigor, and presence of unusual levels of insects or disease, as well as resilience to disturbance. But what's key about forest health is that it's also influenced by the perception and interpretation of other people. Sorry, let me rephrase that. The perception and interpretation of forest health, so how we think about forest health in a given area, that it's influenced by individual and cultural viewpoints. It's influenced by land management objectives, spatial and temporal scales, as well as the relative health of the stands that comprise the forest and what it looks like at a given point in time. Meaning that the definition of tree or forest health today might look different in 10, 20 years, and the definition of forest health today might look different than what it looked like 20, 40, 100 years ago. So there are many definitions of forest health, and there are often miscommunications about what people, foresters, and forest managers actually mean when they say forest health. So how do we diagnose tree health problems? Where do we start? This is often one of the most common questions that I receive as an extension forester, which is the call of why is my tree dying? Or what's wrong with my tree? Um, and a common answer to that is it's usually a complex interaction of biotic, living, and abiotic, non-living factors, and usually a little bit of bad luck. So today I am not going to spend a whole lot of time on digging into different biotic and abiotic factors. There's a lot of resources available online to learn about the agents that impact and affect tree health, and there are people who are much more expert at that than myself. They also have been studied for decades. A lot of these forest pests and pathogens are native. They've been around for as long as forests have been around, and researchers and foresters have been studying them for a very long time. So this includes insects, like in the photos shown here, we've got Douglas fir bark beetle on the right, and then we've got signs of laminated root rot with the folks looking at a fallen over tree on the left. But today, what I wanted to focus on was looking at some tree species declines as well as novel threats. So the declines that I want to talk about today are for three species. And this is stuff that's been coming up a lot in my work, both amongst my colleagues, but also when I'm out talking to landowners and learning about what's happening on the ground for folks. So I'll talk about red alder decline, western red cedar decline, as well as big leaf maple. So red alder dieback, this has been something that researchers have been keeping an eye on for the better part of 10, 15 years. Um, and the symptoms are crown dieback, so the crowns are losing some of their leaves at the top, and there's abnormal mortality and thinning branches up at the top. And then there are signs of canker, which are the wounds and sap that are on the stem of the tree or on the bark. And the pattern of how this emerges is that it's usually in stands of alder, roughly 30 to 40 years old, and it's usually in the context of warmer temperatures or in drought-prone stands. What's confusing is that alder is not a relatively long-lived tree, that it typically sort of tapers off in terms of its lifespan around 60 to 70 years, but there has been a pattern of shorter lifespan and increased mortality. There's ongoing research that's looking at this. So there was a 2015 research study that talks about and was investigating the potential impacts of a phytophthora, which is a water mold that is normally found in Europe and impacts alders in Europe. And they were looking to see if it had emerged in Northwest North America. Um, Conclusive that it was not the same phytophthora, but there was like a different phytophthora that was found. And then there's ongoing research at OSU that's looking at additional threats to alder health, including different bacterial species. So this has been one that I've been following particularly closely over the past year, just observing these um, cases of big leaf maple dieback on hikes and trail runs, and also when visiting landowners, is that there has been, an observed decline of big leaf maple across the Northwest. And what this looks like is similar to alder. It's got a gradual top-down decline, right? Those uppermost branches are dying and fading, dropping leaves, thinning out. Um, We've got epicormic sprouting that can occur on the lower branches or the lower parts of the trees, which is an indication of stress. Often, big leaf maples that are experiencing decline will drop their leaves early. They'll have generally sparse crowns, and eventually it can lead to mortality. You'll also see a wider variation in terms of leaf plasticity. So big leaf maple do have a range of leaf sizes, larger leaves at the base and the shade leaves, and then smaller leaves at the top where it's more exposed to wind. But trees that are in decline are seeing an even wider range of leaf size. Um, so the study from Betson and Alia from 2021, this was looking at sites in Washington state, and their original findings were showing that there was no associated plant pathogen or insect herbivore that was associated with the decline. They were finding that basically that this was being caused by site conditions, so that the decline was more likely to happen on hotter urban sites or in sites that were particularly drought prone. However, there is ongoing research to see if leaf hoppers, which are a sap-sucking insect, um, if they are correlated with this decline. So this is the leaf hopper is Empoasca elongate, which is this primary insect, and it feeds on the leaves of big leaf maple. And the Forest Service and several other partners are working to try to clarify the relationship between feeding leafhoppers and tree decline. So they came up with a trapping method and a protocol, and have been monitoring tree canopies of big leaf maple with sticky traps. And they've also been conducting insecticide surveys as well as roadside surveys. And they think that there might be a relationship. And the photo that you see on the right here shows two instances of trees, groupings of trees, with one being a control that wasn't treated with imidacloprid, and then on the right you've got the treated tree that shows a much more full crown. So again, this is a complex interaction of climate, of insect damage, and it takes a long time and a lot of research to try to tease apart these interactions. And then a big one that we are also seeing across our region is Western red cedar dieback. And I think there might have been a question submitted to the Master Gardener group before this webinar around this. And this is something that I have been talking a lot about and learning a lot about, and seeing it across my counties. So beyond Oregon, it's throughout Oregon and Western Canada, and it's there there has been a lot of individual Western red cedars and groups of red cedars that have been dying in places where it should be thriving, where historically we've found Western red cedar growing full canopies and growing healthy. So this is often along streams, often seasonal streams, or even within closed canopy forest. This decline and dieback is currently unknown, and it is sometimes sudden. Insects and diseases of Western red cedar are typically secondary, which means that they're not direct tree killers, but they're opportunistic pests and only attack dead and dying trees. Additionally, red cedar can even tolerate endemic levels of bark beetles and stem decay for many years and still persist. But Western red cedar is very sensitive to slight changes in abiotic conditions, right? So that slight change of water table that I talked about earlier, that can mean the difference between survival and decline. And that there's a lot of research going into understanding how range contraction might actually be occurring for the species, that the furthest fingers of Western red cedar habitat where normally it has been able to thrive, that we're seeing a retreat of that potential area for the species to grow and thrive. A lot of the dieback in our area that we see is likely associated with that heat dome event in 2020, 2021, that the effects of that super high temperature for the few days, that the impacts of that are actually maybe not seen for several years afterwards. So moving on from the declines into the more novel threats, these are big picture stuff. They're in the news. They're high headline material because they're really significant. So today I'll talk about three. Um, I'll focus more on emerald ash borer and Mediterranean oak borer, and I'll mention spotted lanternfly as well, though I'm not working as closely with that as much. So emerald ash borer, um, this has been particularly in the news recently because it was recently discovered in Multnomah County. There's been a lot of PR and media coverage of this expansion of the invasive insect. So it's native to Asia and it arrived in the US in 2002, but it was first discovered in Oregon in 2022. It's a wood-boring beetle that feeds on ash trees. So this is the Fraxinus genus. In Oregon, we have a native ash tree, the Oregon ash, which is an incredible tree and grows in really unique soil conditions and is super important for wildlife habitat and for riparian areas and stream temperatures. EAB lays eggs on the bark, and then the larvae move into the tree and feed on the inner bark of the tree, and over time disrupt the nutrient flow going from roots to stem and shoots. And the larva may live for 5 years in the tree before it actually causes mortality. The first discovery was in Washington County in the Forest Grove area. Then they found a second grouping over in the Marion Clackamas Yamhill sort of uh, boundary. Though there was some debate about which one was older, that expanded the quarantine zone to multiple counties and now recently has been discovered in Multnomah County. There's been an amazing multi-agency, multi-stakeholder response to EAB that has been going on over the past 3 or 4 years now, following a plan to try to slow the spread of the beetle and to reduce impacts, especially on urban communities and municipalities. So the signs and symptoms of EAB, symptoms in the tree itself is canopy decline, epicormic sprouting, woodpecker damage, and bark splits. What's tricky about Oregon ash is that often Oregon ash sometimes has canopy decline and has epicormic sprouting anyway. So What the key thing to do is look for the signs, and the two main signs are D-shaped exit holes that are about the size of a pencil tip, as well as larval galleries in that inner bark, showing that there's been presence of a larvae moving in that area, feeding on the phloem. What to do about emerald ash borer? This is the big question. The first thing that we recommend is monitor. So learn how to identify ash trees and learn if you have them in your area or on your property and monitor their health. This could be looking at them periodically throughout the year. It could be having a set date in the winter and the summer where you go out and you look at the ash trees. Um, there are options for treatment. This is a preventative treatment, so it needs to be done on healthy trees. The most common compound that works the best is emamectin benzoate. You can use this once every 3 years to maintain the health and vigor of the tree, and is proven to be effective, though it can be expensive. However, it's typically less expensive than getting the tree removed by an arborist. Um, so the main thing there is that you're really going to want to focus on trees that are high risk to life and property. And then once those trees are down, coming up with pathways to dispose of that wood material without moving it as firewood. That's one of the main vectors for the beetle and the larva is in firewood. There's a ton of resources on EAB. Oregon has an incredible repository of information available online at OregonEAB.com. And there are folks at the Oregon Department of Forestry whose entire job is focused explicitly on EAB communication, education, and outreach. So a new novel pest is the Mediterranean oak borer. We just got an update about this today that it's shown to be more prevalent across the Willamette Valley than they first thought. It's an ambrosia beetle native to Europe, Western Asia, and Northern Africa, and was introduced in California, likely through wine barrels. And the beetle itself doesn't actually kill the tree, but it carries a fungus that infects the wood and eventually causes the tree to decline. Since 2011, it's been killing healthy and unhealthy oaks in California and Oregon. But the recent trapping results from this past summer show that it is more widespread across the Willamette Valley than they thought. Um, right now, the current infestation and removal rate, so they've sampled around 988 oak trees. They've found 4% were infested and then removed those. So the jury is still out on how detrimental this will be to the oak population, which is really good news because Oregon white oak is a critical tree for wildlife habitat um, for many communities, and we really don't want to see them be wiped out by an invasive pest. So some of the symptoms to look for are canopy dieback is the main one. However, this can be confused with other damage, such as storm damage, drought damage, or gall squirrel damage. Other signs to the signs to look for here are going to be frass, which is the boring dust from the beetles on the outside of the bark. But this can be hard to see and can be swept away by wind and water. And then the black stain brood tunnels within the actual wood is another indication of Mediterranean oak borer. So similar to ash, identify any oak trees that you have or that are in your area, monitor their health and prune them. And this is important, but to establish a root protection zone around those trees. Treatment options are still being developed. There's no specific guideline yet. There's some proven efficacy of a preventative pesticide and fungicide combo, but it's not well documented or confirmed yet. Um, if you confirm you have MOB in your tree by an expert, by a state expert, then you would look towards removing it and disposing of the wood. But right now, they're not recommending stopping planting oak trees or continuing to manage oaks because they're still a really important tree species across the landscape, and most of their habitat has been lost already. If you want to learn more about this, I recommend checking out the ODF Forest Health site to learn more about MOB and approaches for management. Spotted lanternfly, I mentioned also just because this is a really important pest that ODA and ODF has ongoing monitoring for. Native to China and Korea, and it has a massive threat to fruit trees and grapes, which is especially important for Oregon. It prefers to feed on tree of heaven, as well as grape species, but it can feed on 70 plus other plant species. Its main vector of spread is through egg masses. And the big news is that there was a report of a single adult in Portland in 2025, but there continues to be ongoing monitoring by ODA, especially looking at like shipments coming in from the different ports, looking for egg masses. Um, so thinking a little bit about resilience, we've talked about trees that are declining. We talked about invasive pests that are affecting tree health. What can we do, right? One of the things that we talk a lot about is adaptation and thinking about concepts of adaptation that we can do on small scales, regional scales, and larger scales. So adaptation is the adjustment that we can make to our plant communities as we think about the actual changes in climate or the expected changes of climate. There's a variety of different approaches to this. There's ways that people might change species composition within their property or in their forest. They might reduce density to reduce that competition, or they might pursue more novel approaches such as assisted migration that can hope to enhance resistance and resilience to disturbance as well as changing climate conditions in the future. Um, Adaptation might look like protecting what you already have. But adaptation might also look like accepting the changes that are coming and working with your forest to nudge it or your property and to nudge it in a different direction. Or it might be as significant as directing that your property or your forest by planting new species and by removing declining trees and thinking about what you want your future canopy to look like. Um, and the main thing is that as we think about this, one of the key things is to really understand your site. What are the conditions that I'm working with on my given property? What kind of sunlight do I get? What are the soils? What's the topography? What's the water availability? And specifically, how might it change in the future? And even with that range of variability, what do we think it might look like? So I'm not a plant expert. There are many people and there's so many resources out there that go into detail around the many native plants in Oregon that are great for landscaping, for forests, and beyond. The three species that I've been thinking a lot about as being climate resilient are Oregon white oak, despite MOB, the Willamette Valley ponderosa pine. So it's that subspecies of ponderosa pine that grows in the Willamette Valley. This is a great tree for those drought conditions, warmer summers, um, and can often grow in places where it's periodically wet. Incense cedar is also a common tree that is used in these droughtier sites or places that are experiencing warmer temperatures, especially in the lowland valley areas and the valley margins. And there's a lot of emerging research and study around different species of redwood and using those at beyond just landscaping approaches. So there's a recent publication that just came out from OSU looking at the two different species of sequoia, Sequoia sempervirens and Sequoia giganteum. Both are really interesting options, and um, always keep in mind, though, if you are looking towards non-native trees, about the potential impacts on your wildlife habitat, as well as other trees. All right, I will now hand it off to Sarah.
All right, awesome. Thank you, Jake. That was great. So many of the things that Jake just discussed also apply to the urban landscape. Trees in urban and suburban settings still need sunlight, they need access to healthy soil and adequate water. Trees in urban areas are also impacted by stress from environmental and biological factors. And in urban areas, trees also tend to have to deal with all these like infrastructure issues and cultural practices. For example, in these images, we can see that this beautiful tree is kind of basically in a giant container at the corner, surrounded by impervious surface on almost all sides. And then the trees on the right, you can see that they're like right underneath a power line, been really expertly pruned to make that even possible. And then on either side, the root zone is the road, big road, and sidewalk. You can go ahead. Jake, you want? Yeah, okay, thanks. So another thing about urban areas is that there's a diversity of trees, and with that diversity of trees is also a diversity of associated challenges. Urban and suburban areas are home to a wide variety of plants. If we were to look at Hoyt Arboretum in the Portland area, there are 2,300 species of trees and shrubs. OSU Corvallis Campus Arboretum has 600 species of woody plants. And not all of those are trees, but a lot of them are. And each of those trees has their own sort of set of vulnerabilities. So trees are planted all over the world. Trees from all over the world are planted around homes and parks, campuses, businesses, so on. And this diversity helps make urban forests more robust in the face of changing conditions. But it also means that we have a lot of different possible things that can go wrong with these trees. You can go ahead. Okay, so decay, one thing I wanted to mention is that decay is good. Decay has ecological value, it is inevitable, and it's not always hazardous, even in an urban environment. It's important to note that just because a fungus, insect, or other organism can cause trees to decline, that does not mean that it's necessarily going to, and it's not necessarily a bad thing. For instance, in a healthy forest, bark beetles can create snags and cavities used by wildlife. In a Douglas fir-dominated forest, laminated root rot can lead to gaps that allow hemlocks and western red cedar to have some space to grow. And even in an urban environment, a dead branch can be a perching spot for birds. But in an urban environment with all that infrastructure, with all those folks walking around and going in and out of their cars, walking down streets, going into their houses, we want to keep people safe, right? So we know that trees can die. It's a natural process. They will die. There's an expression from Kevin Smith at the U.S. Forest Service that all walls fail and all trees die. And the consequence of being a living organism is that eventually a tree will die. And in a forested environment, that tree might fall and contribute to the ecological well-being of that forest as woody debris. But in an urban environment, when trees fall, or as we often call it, fail, they can be dangerous. And we want to mitigate the risks of trees failing by monitoring trees and understanding their health. And so we're back to this, what's wrong with my tree? If we want to know what's wrong with the tree, we need to be able to treat the tree, mitigate the risk, take other actions to prevent harm. But how do we know what's wrong with your tree? So we can go ahead and go. Some problems might be really obvious, while others might be a little bit more obscure. And the first thing to do when we get started with this like diagnostic method, I really like the one that Joe Boggs put together with others at Ohio State Extension. They developed something called the 20 Questions Plant Diagnosis Fact Sheet to help people work through all these different questions that they might have that might help them get to a point where they understand what's going on with their tree. And this first question is probably the most important one. What kind of tree is it? As we saw before, not all trees are impacted by the same things. And so if we know what kind of tree it is, we can eliminate a lot of other possibilities. And if you don't know what kind of tree it is, you can use a tool like iNaturalist to kind of narrow it down to a few different plants that it might be. The next question is, what's normal for this kind of tree? And we can figure that out using some of the resources that are available too. There is this Pacific Northwest Plant Management Handbook, and in this handbook is a variety of plant diseases and insects and pathogens that can impact trees, and it's all based on the species of the tree. So once you know what kind of tree it is, you can go in and see what possibilities there could be that are impacting your tree. Which gets back to that, what are the common problems for this tree? I also want to think about, what do you see that looks abnormal? Just an example here that sometimes when we see something that looks abnormal, it doesn't necessarily mean there's something wrong. Sometimes we get photographs of a bark with, somebody will say something like, I'm worried about my tree, it has these white spots on the bark. and then we'll look at the photograph and we'll see that it's lichen. And we know that lichen is not only not bad for the tree, it is good for the tree and the environment. Then we also want to look at, oops, sorry, not quite. One more question. What is the overall health of the plant? And that can help us kind of determine not just what's going on with the plant, but also get a kind of sense more holistically of whether the whole plant is really impacted, and just give us a sense for like, are we taking in the whole picture basically? And then there are a series of other questions. There are 20 altogether. This is the first 10. I'm not going to go into all of them, but yeah, Jake, we can go ahead and go forward. But there are a few others that I want to highlight. This other one is, what is the environmental history of the site? We can think back to what Jake was saying about changes in climate and how that is impacting forests. And we can think that those changes in climate are also happening in the urban areas in Oregon, and in some cases might even be amplified by urban heat island effect. So we might even be able to see that there are things happening even that are even more obvious in urban areas, stress trees and that kind of thing. So when we think about the environmental history of the site, we can think about individual site. For instance, did somebody just dig a trench across the yard that cut into roots? And then we can also think about this larger scale issue of what's happened to the climate. Another couple of questions I wanted to highlight are, what diagnostic tools are available? There's so many resources available out there, and once you get to know them, it gets easier to figure out when to apply them. Just to give you an example, the OSU Plant Clinic has a service where they can help determine if you have, say, Phytophthora or armillaria in your site, and there are instructions on the website for how to collect a sample and send it in, and there's a cost to that one, but when some of these diseases and pathogens are kind of mysterious, in the way that they're similar to other ones, and by using some of the tools that are available, we can kind of narrow it down, making it not just so that we can figure out what's wrong with this tree, but we can also prepare for what to do next. And then lastly, I want to just mention, what is the significance of the problem? Sometimes we see things that maybe don't look great and are a problem, but they might not be life-threatening to the plant or a source of hazard. So we might not need to really take any action. We understand what it is. We can feel a little relief with that understanding and kind of move on. Okay, go ahead. So another way to think about this is through the disease infestation triangle. And this is just kind of like a different framework for thinking about plant health and diagnostics. The disease triangle illustrating the phenomenon of plant disease as the interior space of a triangle with the three essential factors: susceptible host, favorable environment for disease, and pathogen at the vertices. Variation in the strength of contributions of these factors to the relationship is indicated by the size of the circle, will quantitatively alter the severity of the disease, which will be shown by a change in the area of the central disease envelope. So keeping in mind here that that not all tree problems are biological in nature too. So we can kind of see these different pieces that need to be present. If you've seen a fire triangle, it's the same idea. Like you need to have the pathogen, the susceptible host, and the favorable conditions, or it won't happen. Likewise, sometimes, or not likewise, but so sometimes it's not biological too, and we need to kind of keep in mind that, especially in the urban environment, it could be compaction, construction, injury due to something like improper pruning, as well as just environmental changes, as mentioned before. And sometimes we get kind of stuck thinking like we need to diagnose the disease, when in fact it may be that somebody has hit the tree with a mower and the tree is suffering from that cultural practice. Go ahead. So just kind of going into this a little bit more, diagnosis tree health problems. The primary agent is the cause of the tree death, and the secondary agent is the thing that damages the tree. And really here just want to highlight that the thing that you're observing with the tree, and in this case can also be in an urban area, you might see, say, sign of insect damage, but that might not actually be the thing that has caused the decline in the tree. It may be that the tree was declining due to drought stress or a cultural practice or something, and that stress tree then gets a secondary agent that is kind of taking advantage of the stressed tree. Okay. And I think maybe we'll just pass this one and move on to this. So let's say you've gone through all these questions, these 20 questions. You're looking at your trees and you're thinking, I still don't know what it is. I still feel like there's something seriously wrong with my tree, but I don't know how to address it. So we have an Ask Extension resource that's available to you. You can go to Ask Extension, put in your questions, send some photographs, and then be able to get an answer. It'll be assigned to somebody in Extension who is most likely to have some understanding of that issue, and you'll get an answer within a few days. You can also come to Tree School in March, where we will be covering topics like these for a huge program. And then if you do, you can go ahead, Jake. If you do find that this is a real problem with your tree is in fact not healthy and not safe, you can call an arborist. And when you call an arborist, I recommend to people usually to go to treesaregood.org, which is a website that's supported by the International Society of Arboriculture. It's a certifying organization. So anybody who's listed in here has already demonstrated that they have some experience, that they have a lot of experience with trees and tree care. And then even better yet, you find somebody who is tree risk assessment qualified, which means they've done a second level of training and they passed another exam. And those folks are trained to do a little bit more when it comes to things like diagnostics. Okay, so next up we have, Jake, did you want to talk about this? Staying up to date, we have this ODF Forest Health page. Yeah, go ahead and chime in if you want.
Yeah, I was just briefly, if you're interested in learning about like more regional stuff around forest health, you can check out the ODF Forest Health page, which will post periodic updates and has a bunch of resources on it. And you can also sign up for those updates that you can get emailed to you every month. And then as well, always a plug for Tree School in March to learn absolutely everything you might need to know about trees and owning forest land in Oregon. We're also going to send out a PDF after this with a bunch of resources and links to stuff that we've referenced today. So this is just a brief citation site, but that concludes us, and we have a few more minutes for questions. But thank you so much, and thank you again to Sarah for joining.
All right. Well, thank you both very much. I know a lot more now than I did before, so this is great. Let me go into the questions now. First, I have to say, Jake, you didn't really explain root protection zone very well because 3 people would like you to explain it again.
That's a good question. The root protection zone, I didn't have a photo of it in here, and Sarah, feel free to chime in on this as well. So the root protection zone is essentially an area around your tree that is going to cover that potential zone of roots. So the main thing about roots is that trees have been growing for a long time. They've established their root system. They figured it out. So the one thing that you don't want to do is you don't want to go digging around trying to figure out where the edge of your roots are. So we use the crown of the tree, so the canopy, as a sort of estimation of where the roots are. And you'll use the drip line of the canopy So where water would fall if it was raining, right? So that outer edge of the canopy
Okay.
would be the edge of the root zone. And this is especially important if you're doing any sort of like, uh, yard work or management around a tree. It's something that arborists do a bunch, or folks who are working in urban areas, to protect trees so that the roots aren't damaged. And it's especially important for shallow rooted trees, like Oregon white oak it's important for MO for increasing resilience to Mediterranean oak borer and sort of overall health. But it's important for Western red cedar also. Sarah, do you want to add anything?
Okay.
I'll just
Right.
add that whenever you're doing construction specifically around a tree that involves some excavation or something, there's also the critical root zone, which can be calculated based on the diameter of the tree. So the point really is that the size of the tree does matter, and that we want to get the largest possible area of protection for those roots. And realizing that just protecting the trunk doesn't actually protect the tree, because when you impact those roots, you really do impact the rest of the tree.
All right. Thank you. And here's another one. How can I determine if a particular tree is suffering from lack of water versus suffering from a VPD issue, regardless of how it's watered?
Um,
Tricky.
that's a good question. I think it's really hard to know. I think it's really hard to determine and disentangle the increased impacts of vapor pressure deficit and with warmer temperatures, especially in the summer, and drought conditions. Um, I don't know any specific techniques that one could use on a like reasonable scale. That's a great question. And I don't know. I don't know if Sarah has anything, but I can do some digging to see about like implications, or not implications, but just ways that landowners or homeowners or tree owners could test it or look at it. But yeah, that's a very good question.
Okay, and here's another one. Could you comment on how road, sidewalk, below ground infrastructure can disrupt underground water flow and availability to trees?
Yeah. Um, So if you think about tree roots, and you think about the fact that they need soil volume in order to do all those things that they're grabbing onto rocks and soil so that they can stay put. They are seeking out air, and they are seeking out water and nutrients. So in order to get that, they need to have good soil volume. The more infrastructure you have, the smaller that soil volume is, and the smaller you could basically imagine that trees go from being, maybe adapted to being having roots spread out. Most trees have roots in the top 2 feet of the soil, so it's not like those pictures where there's a canopy that's round and then there's an underground that's matches
Yeah.
that. It's really that there's this canopy and then there's this massive network of roots that want to go outward, in the top 2 feet of soil. So every time you infringe on that with a road or a sidewalk or below ground, you're going to impact the available soil volume and all the things that come with that. So the water, the oxygen, and the nutrients, and stability.
And and yet it's amazing to me that so many trees do live in parking strips,
Yes, they're
right?
adaptable and amazing. Yeah, agreed.
Here is someone asks, what was the acronym BPD? I don't remember seeing BPD.
Yeah, B as in boy.
Yeah,
Um, I don't know. Maybe they were hearing me say VPD and it sounded like BPD.
I bet that was it. I
Yeah.
bet that was it. Yep. Um, and so can you suggest trees to take the place of Oregon ash?
Yeah, I almost included that in the slides, and I didn't ultimately, due to short time. But yeah, there's a really great resource. George Kral is the main author on it. It has a really helpful chart. Yeah, it's a short paper. It has a bunch of writing too, but there's this really great chart and I can share it afterwards as well. That shows trees that are good candidates to replace Oregon ash based on two things. One is clay tolerance and clay intolerance. So the thing about Oregon ash that's so incredible is that it often is growing and thriving in these places that are literally underwater for like 2/3 of the year or a third of the year. And so finding trees that can actually not only like grow and germinate there, but add volume and take move into the canopy is really difficult. So there's a bunch of different options. Depending on the context, ponderosa pine is a pretty good option. So ponderosa pine can hang out in that kind of wet condition for several months of the year. It's obviously not growing, but it's not going to die. Oregon white oak can also be a replacement. In the other riparian areas, people are talking about using willow. They're talking about using cottonwood. Aspen is also thrown out there as an option. Um, so there's a handful of different species, but it's really going to depend on what type of soil you have. The other key thing that some research is emerging is that if your context is looking more at stream shade and maintaining that shade layer, that even if you can't get trees, that having just any kind of shade is going to be really important. So um, even if it's a shrub component, that the shrub at least provides some shade. And the big concern is doing preemptive planting where possible of alternative species, because when we see this sort of sweep of large scale canopy dieback of ash dominant forests, the first thing that's going to grow there is going to be invasive plants. It's going to reduce diversity. It's going to take over the growing space. So trying to get some stuff established now, especially if you're in the areas nearby where EAB has been discovered, I think that's a really good call. Again, a bunch of resources are on OregonEAB.com, especially some pathways for thinking about management depending on your context. So whether or not you're a homeowner with one or two trees, or you're a municipality with street trees, or whether or not you're a natural area manager and you are dealing with a large riparian zone where you would never actually think about cutting down a tree in other contexts.
Yeah.
And there's a variety of different strategies for how you would think about doing inventories, but then also doing preemptive management in those different contexts.
Okay, we've got two more questions. One is, how can this person learn more about the root systems of specific trees? Like, does it have a tap root? Does it have shallow root? She says popular gardening books don't usually give this information.
Yeah, it's a great question. Most trees don't have like the taproot is not significant. It's mostly these large primary roots are going out providing structure, and then there are these secondary roots that are going out in the same way that you have in the branch structure. You have smaller branches going off of the trunk, and they get smaller and smaller. And that's a similar pattern happening in the root zone. Sorry, with the roots. But then you do have these fibrous roots at the end that are doing sort of the water uptake and nutrient uptake. And for many plants, that also means, connection to mycorrhiza and fungus that helps
Yeah.
facilitate that uptake. But it is hard to get specific information on individual species because it's hard work to do. It's very dirty work. You use an aerator and it makes a humongous mess. And so there isn't a ton of research out there, but I think more people are starting to do work on that. I just saw a presentation today about root systems of London plane trees and their sort of tolerance to different root pruning activities. So it's kind of a stay tuned, but you basically assume that there's a lot of roots in the top 2 feet of the soil, and whenever you can avoid disturbing those major roots, it's good.
Okay.
And
And that,
I would quickly add, if you really want to get into it, if you want to do some deep dive, look at the Silvix of North America. So SILVICS. Silvix of North America has hardwoods and conifer species, and it goes into quite some detail around each species. And some of them do have rooting habits. So if you want to do a
okay,
deep dive, that's a resource I use.
excellent. And the last question, which sort of ties in here, is can you speak to the pros and cons of mulching around a tree?
Mm.
Yeah. So mulching is generally a great thing to do if we're talking urban and suburban landscapes. Um, Mulching can reduce the loss of water out of the soil. So it has that insulating effect. It can also, like just practically speaking, keep mowers and weed whackers and stuff away
For
from the
sure.
trunk of the tree, which is like a huge loss. A lot of trees get lost just from this simple cultural act of hitting the tree with a lawnmower or a weed whacker.
A
The
weed
trick
whacker,
though
yeah.
is, I bet that most of you are kind of already on this page, but we want to stay away from those mulch volcanoes where there's mulch leaning up against the trunk. The trunk is adapted to, be exposed to air, and when we put the mulch on top, it creates more of a soil environment, and then you start seeing some decay or impact to the bark on the outside of the tree. So always trying to keep that mulch away from the bark of the tree. And then I generally recommend like 2 or 3 inches deep and in a kind of a donut shape around the tree. But it's a great thing to do, and it does help, especially if you're in an urban environment with not a lot of actual soil and you're maybe in fill conditions. You can kind of add
Yeah.
some good organic matter to the soil that way.
Well, Sarah and Jake, thank you both very much. This was very helpful information, and I think we all know a lot more than when we started the evening. So thank you very much. We're now going to switch over to our chapter meeting. So everybody who's not a Washington County Master Gardener can dial out now, and we'll move on to our meeting.
Sounds good. Thanks for
Thank
the